Hello everyone, you are welcome back to my class. Here is a continuation of 2025 NECO past question solution series on physics. So far we have done up to question 7, the theory part 1. So we're going to continue from there, question 8. So we're going to continue from here, that is question 9 in today's class. So question 9 says, state one reason for preferring potentiometer to a voltmeter for measuring EMF of a cell. And 9b says differentiate a conductor from an insulator. So the main reason why it is preferable to use potentiometer instead of voltmeter, that is question 9a. So question 9a, the reason is that potentiometer does not draw current while measuring the EMF electromotive force of a cell. Is that understood? So in the case of voltmeter, it draws current in the course of measuring the EMF of a cell. So this potentiometer measure the actual value of the EMF compared to voltmeter. I hope this is understood. So that is about question 9a. So 9b says you should distinguish between a conductor and an insulator. So what is a conductor? It could be a conductor of heat or electricity. So conductor in general, conductors are materials that allows the passage of heat or electricity through them easily. That is conductor. So while insulator, or you can also call it a non-conductor, non-conductors, insulators or non-conductors are those materials that does not allow heat or electricity to pass through them easily. So that is about question 9a and 9b. So let's quickly add question 10 in this session. Question 10 says you should distinguish between adhesion and cohesion. So B says, why is the level of mercury in a capillary tube deep in mercury depressed? So that's the question 10. So question 10 says, question 10a, you have to differentiate between adhesion force and cohesion force. So adhesion force is the force of attraction. Is the force of attraction between molecules, between molecules of the same substance, between molecules of different substances, like force of attraction between water molecules to glass molecules is an example of adhesion force, while cohesion force, or force of cohesion, is the force of attraction between molecules of the same substance, of the same substances. Example: the force of attraction between molecules of mercury to mercury, or the force of attraction between water to water molecules. So that is a cohesion. While between maybe mercury to glass, or between glass to water, they are force of adhesion. Is that understood? So that is about question 10A. So question 10B. So question 10B says, said, why is the level of mercury in a capillary tube dipped in a mercury depressed, right? So why is it depressed? So for instance, we have this, right? So let's say here is mercury, then we have a capillary tube, right? So when this capillary tube is inserted, it's supposed to rise. If it was to be water, it will rise, but in terms of mercury, it will depress below the level of what? Of the one here. So it will depress. So the question is, why does it depress instead of what? Rising. Are we together? So why does it depress? It is because of this adhesion and cohesion force. So the force of adhesion is the force of adhesion between molecules of mercury to mercury is greater than the force of adhesion, the force of cohesion between molecules to glass molecules. So that is why it depresses. So this is adhesion force between mercury molecules is greater than the force of cohesion or adhesion force. Let's say adhesion force between molecules, mercury molecule, is greater than the force of the cohesion force. That is the cohesion force. The cohesion force between mercury molecules is greater than the force of adhesion between molecules of mercury and molecules, let me put it like this, of glass or glass molecule, right? So the cohesion force between molecules of mercury to mercury is greater than that of what? Between mercury molecules to glass molecules. So mercury tend to what? Clinch together. So that is why it depresses. Is that understood? So cohesion force is greater than adhesion force. Also, in some question now, they might ask you why water wet glass and mercury does not wet glass. It's the same reason. The cohesion force between the mercury to mercury molecules is greater than the adhesion force between mercury molecules to that of glass molecules. Is that understood? That is about question 10b. So to cap it all for today's session, I think we should add question 11. Question 11. So question 11 says, what determine, Roman figure 1, maximum kinetic energy of an electron ejected from the surface of a metal illuminated by a radiation, and what determine the intensity of X-ray produced in an X-ray tube. So question 11a, Roman figure 1. So the energy of the photon that is incidented on the metal surface, right, which result in the ejection of electron, the energy is given to be E equal to hf. H is the Planck constant and F is the frequency. So what determine and this energy, lest I forget, when it is incidented on the metal surface, it is what gives the electron what is known as a work function. It is summation of work function and the kinetic energy needed for the electron to move from the metal surface. So the thing that determines the kinetic energy here, the maximum kinetic energy needed by the electron, ejected electron, to move from the metal surface is the frequency. So the whole answer to this is just frequency. So this could be objective also. So it's frequency. The answer here is frequency. This one is just an explanation. So the answer here is frequency. So just take note of this because this can come in exam. What determines the maximum kinetic energy of an electron ejected from the surface of a metal illuminated by a radiation. So that's about that one. Roman figure 2 said what determines the intensity of X-ray produced in an X-ray tube. So this one is the number of electron. So that is a number of electron that can add it like this, that strike the target per second. So that is about question 11a. So 11b says calculate the energy of a photon of wavelength given that wavelength lambda is 6 times 10 raised to power minus 7 meter, and Planck constant H is said to be 6.6 times 10 raised to power minus 34 joule second, and C is given to be 3.0 times 10 raised to power 8 meter per second. Is that correct? And we're looking for the energy of what? Of the photon. So what is the formula that relates the energy of the photon and all these parameters given to us? Remember, we have that E, the energy of the photon, is equal to hf. So, but in our parameters here, there's nowhere they give us f, the frequency. But we have that from this famous wave equation, V is equals to what? F lambda. Is that correct? So the V here is going to be the speed of light, which is C, equal to F lambda. So which implies that lambda frequency is equal to C all over lambda. So in this our equation, E equal to hf will now be equal to hf is C over lambda, shall become hc all over what? Lambda. So from here, our E is now equal to, what is our h? Our h is given to us to be 6.6 times 10 raised to power minus 34. Is that correct? Multiplied by C, which is the speed of light, that is 3 times 10 raised to power 8, all divided by what? All divided by lambda, which is 6 times 10 raised to power minus 7 meter. Is that correct? So from here, if you multiply the numerator, you have 6.6, you press this exponential, raised to power minus 34, you see it, multiplied by 3 exponential 8. I hope you get it, equal to, so I have my answer to be 1.98 times 10 raised to power minus 25 all over 6 times 10 raised to power minus 7. So that my E will now be equal to, so whatever you have as your answer here, you can just press divided by 6 exponential what? Minus 7. That will give us what? 3.3 times 10 raised to power minus 19 joules. So this is where I'm going to stop today in our class. Thank you for your time. See you in the next class.